Hi, I'm going to show you how to find a common denominator between two fractions so you can order them and compare them and also later on add and subtract them. So the first thing that I have to do is find a common denominator. The denominator is the bottom number of a fraction. The top number is called a numerator. So in order to compare, order, add or subtract fractions, we need to have a common denominator. That means a denominator that is the same for both fractions. So some strategies that I can use are the following. The first strategy I can use is I look to see, can the lesser denominator multiply to equal the greater denominator? So I look, this is lesser, 5 is less than 7. Can 5 multiply to get to 7? No. So I'm going to move on to step 3 in a second. However, if it did multiply to be able to get that, whatever number I would multiply this denominator by, I would multiply the numerator by it as well. This number, this fraction, 8/7, would stay the same. However, it does not. So what I have to do is I go on to step 3. If not, find the lowest common multiple, the LCM, the smallest same or common number both denominators each can multiply to. Okay, and then in this case, both fractions will change. So is there a number that 7 and 5 can both multiply to? That's the same number that will be the resulting denominator. Usually we try to find the lowest one. Okay, in this case we're going to go with 35. I know that 7 can multiply to get to 35 and 5 can also multiply to get to 35. So that will be my common denominator, both the same. So then I ask myself, what did I multiply 7 by to get to 35? What did I multiply 5 by to get to 35? So whatever I multiply the denominator by in a fraction, I have to do the same thing to the numerator. It's a rule. Okay, so 8 times 5 and 7 times 5, 4 times 7 and 5 times 7. Okay, so 4 times 7 is 28. I've already done 5 times 7 to get this. 8 times 5 is 40. 7 times 5 is 35. So now I can compare and order them. 40 over 35 and 28 over 35. Okay, so I'm now on this one, that this symbol is greater than, this symbol is less than. Okay, and there's also equal to. So 40 over 35 is greater than 28 over 35. Okay, so that's one way of how to do that, to be able to compare them. Okay, now a different way that I can do this is by using number lines. I can use my original fraction, 8 over 7, and then the other one, 4 over 5. I have a number line. If I'm comparing two fractions, the number lines need to be equally lined up, so the same length. So I deal with my first fraction, 8 over 7. 8 over 7 is an improper fraction, so I can convert it to a mixed number if I would like. Okay, so 8 over 7. How do I do that? Well, I always divide the denominator into the numerator. So 7 times 1 is 7, and then I do the math. This always is the denominator. It always stays the same. Okay, this quotient becomes my whole number on the side, and this remainder becomes the numerator. So this is the whole number, W, this is the denominator. Okay, so my mixed number fraction, 1 and 1/7, is equal to, or equivalent there to, 8/7. So I have my first number line, which will be the 8/7. And how do I know how much a whole is going to be? So it says in the denominator. The denominator tells me how many parts will make up the whole. Okay, so I start here at 0. 1, 2, 3, 4, 5, 6, 7. Because it's in 7 parts by the denominator telling me. So this equals 1 whole. Okay, my fraction is in a mixed number 1 and 1/7. So I have the 1 whole here for this, but I have a second part of the fraction which is telling me that there's another whole part of 7 parts So I have to go 1, 2, 3, 4, 5, 6, 7. So this is 2 whole parts. Okay, so I can now plot this onto this number line, 1 and 1/7. So here's 1 for the 1 whole part, and 1 out of 7 parts. So this is the first one, which is 1, starting again, 1, 2, 3, 4, 5, 6, 7. Okay, this is the first part here, which represents this, and the 7 represents that there are 7 parts. Okay, 1 here, the whole number just means 7 out of 7. Okay, so this is representing, this dot is 1 and 1/7 or 8/7. I double check. 1, 2, 3, 4, 5, 6, 7, 8. Yes, that's the 8 representing that out of the next 7 parts. So that's my first fraction plotted on the number line. I move down to the next number line and I'm going to do 4/5. 4/5, excuse me. So 4/5 is a proper fraction, so I do not need to convert it into anything. I do know that I need to divide this number line into fifths because the denominator is telling me. So 1 whole part will have 5 be divided into 5. So 1, 2, 3, 4, 5. So where I would write down 1 whole would be here, and it's divided into 5 here. So out of the 5 parts of that whole, 4 of them are used, and I counted out 1, 2, 3, 4. So this is where 4 out of the 5 parts. So that's where 4/5 would be. Now when I compare this line to this line, I can visually see that 1 and 1/7 is here, whereas 4 and 4/5 is here. This one is further this way, so this is greater, and this one's closer to 0, so it is less than. So I know that 8/7 is greater than 4/5. And we already knew that because we had worked it out numerically there. But visually, we can also see it here.